Okay, so we got through the A, the B, and the C. Finally, we have to get through the last part D of factoring out a greatest common factor, the GCF. So you can see D says if a polynomial starts as a negative, you must take the negative as part of the GCF. And the reason why that's very important to take out the negative is because when we're going to learn the other steps, the grouping step, the shortcut, the arch, it's very important that your leading sign has to be positive. For the arch method and for the shortcut, it only works if this is a positive sign in your leading coefficient. So it's very important to double check as part of the GCF and ask yourself, does your polynomial start with a negative sign as the leading coefficient? What I mean by leading coefficient, notice how this first coefficient has a negative. That's what I mean if your polynomial starts as a negative. It doesn't mean that they all have to have a negative sign. It's just that your leading term, if it has a negative, you must take that out as part of the GCF. So let's do the first one. You can see this clearly does have a negative. A little star here. You can see that there's a leading term that's a negative. So remember, when you do your GCF, you should be always asking yourself, A, B, C, and D. So ask yourself, A, do we have matching set of parentheses? No. B, do we have the same letter in every term? X, X, no X. So we don't have a common variable. C, do we have a common number factor? As soon as I see I have a couple of prime numbers here, even if I did this as 3 times 3, I would have 2 3s, a 7, and a 2. There's no common number factor. But notice it does start with a negative sign. So again, we're going to show you in this problem where we're going to have not only D, but we're going to have B and C as well. So every problem, you might have just A, or just B, or just C, or just D, or a combination of them all. Go through the list. We know this has a negative, so how can I factor out that negative? Well, a negative is basically factoring out a negative 1. Okay, so that's anytime that your polynomial starts as a negative, make sure that you take out a negative 1 if there is no number. How do I factor out a negative 1? Remember, we need to get our leftovers. The leftovers will go as one set of parentheses. So for us, to get our leftovers, remember, just like we did for the other types, divide each and every single term by the negative 1. When you divide each term by negative 1, negative 9 divided by negative 1, you're going to get a positive 9x squared. Negative 7 and negative 1 divide it, you're going to get a positive 7x. And then a positive 2 divided by negative 1, you're going to get a negative 2. Notice it's just basically the inverse, the additive inverse. Negative 1 to positive, negative 1 to positive, positive 1 to negative. This would be done factoring out your GCF. Let's take a look at this more complicated problem. We told you you want to go through all the steps. Anytime that I'm looking for a GCF, even though we know it starts as a negative, make sure that you went through A, B, C. Don't start at D right away. So A says, do we have matching set of parentheses? No. There's only a few times that we'll have matching set of parentheses. B, do you have the same letter in every term? 1, 2, 3. Yes, notice that they all have the letter D, every single term. That means we do have a GCF for a common variable. Remember, grab the smallest exponent for that D, 6 versus 3 versus 2. So we know part of my GCF is D squared. Do we have a number in common? Okay, that's part C. We have a 3, we have a 12, we have a 15. Remember, if you don't see it, we suggest to do a tree diagram. So for 3, it's just going to be a 3. Can't break it down any further because it's just 1 times 3. So I'll just leave it as a 3. 12, most of you probably know 4 times 3, which would break down as 2 and 2. And then 15, you know that can be broken down as 3 times 5. We know that these are all prime numbers. You cannot break down 3, 2, or even 5 any further. So you can see without putting them in order, they all have a 3 in common. So not only do they have a d squared, but they also have a 3 in common. So remember, you have to look for not only A, B, C, but now finally D. Does this start with a negative sign? I don't care about this or this. Does the leading term, leading coefficient, start with a negative? If it does, you must make it as part of the GCF. So our GCF is not only d squared, but the 3 and the negative. So here we found B, C, and D. So remember, just because you found your GCF, we still need to find our leftovers. Let me get my eraser. You know how to find the GCF. I'm going to take each of these terms and divide it by my GCF. So I'm going to divide this by negative 3d squared, negative 3d squared, negative 3d squared. Because each of these little problems are like our mini problems. Remember that from section 5.7, our little mini problems? Where do you have more, top or bottom, by how much more? You know that's going to be d to the 4th, and then negative 3 divided by negative 3, it's going to be 1. Do you need to put the 1 there? No, because you know 1 times d to the 4th is the same thing as d to the 4th. So you don't need that. But if you put it in there, they'll still mark that correct. Here, positive 12 divided by negative 3. We know we're going to get a negative, remember, different signs, negative 4. And then 3 d's versus 2 d's, more d's on top by just 1. Do you need that coefficient, exponent as 1? No. You can leave it there, or you can get rid of it. And our final term, negative divided by negative. You remember our tic-tac-toe board if you forgot. We're doing division, so you remember that a negative divided by a negative, we're going to get a positive answer. So we're going to get a plus 5, and then remember, d squared over d squared. If there's a tie, no more d's in this term. So our final answer, when you take out the GCF, is going to be negative 3d squared, and then the leftovers in parentheses, d to the 4th minus 4d plus 5.